Page 1 of the exponential models bookwork, exercise 4R, number 1. Draw the graphs of these functions using your GDC. For each, write down the coordinates of the point where the curve intersects the y-axis and the equation of the horizontal asymptote. So we'll start with this one here. It's f of x equals 2 to the x. It's kind of hard to read these exponents, but it's to the x. First thing you want to do, like most problems and math studies, is if they give you an equation, why not graph it? Okay, and then graph. There we see it. Okay, and then I provided these tables here for you to map out points. The way you see the points, of course, is second table. Here we go. So let's say that we're going to start a graph at 0. So put 0, 1, 1, 2, 2, and 4. Those are the first 3 points. The third one is 3 and 8. Okay. Now let's graph those points. So we'll say that this is the y-axis, this is the x-axis. So 0, 1 would be here. 1, 2 would be here. 2, 4 would be here. And 3, 8 would be here. Okay, and then just connect the points. Okay, so that was number 1. One of the interesting things here is when x is 0, you can see that this turns in, like if I say, what is the function when x equals 0? It's equal to 2 to the 0. And remember that 2 to the 0 is equal to 1. Okay? So anything to the 0 power is 1. So that's 1. Okay? Let's go down to number 4. It's a little bit different because it has a fraction. So whenever you saw how the exponential function grows when you have a certain base to the exponent. Now let's see what it looks like when you have a fraction in the exponent. So put parentheses, 1 divided by 3, close parentheses, and then we'll have to the x power. And then we can graph. But the most important thing is we're going to see the table. And do you see how it's like the opposite? Before, the other one was going up. This one is going down. So we'll look at the table and see what values there are. So for 0, for x equals 0, y is 1. And then there's, for x is 1, y is 0.33, which of course is 1/3. And then it just gets smaller and smaller, doesn't it? These are kind of hard to graph. Okay, so maybe we could still graph maybe 2. It's 0.111. Okay, so maybe we should change the scale here to graph this one. So we could put the scale as I would put like 1/3 here, and then I would put 2/3, and I would put 1. Okay, and so the first point is 0, 1. Just like before, 1/3 to the 0 power is equal to 1. Okay, so that's where that comes from. X equals 1, y equals 0.333, which is 1/3. Okay, so let's put we put 0, 1, 2, 1, comma 1/3. Right, and then the last point is 2, comma 0.1111. So that would be about there. Okay, and then we'll connect the dots. Okay, so you can see that this one here goes up, this one here is going down, and the difference is the base. The base being a number smaller than 1/3 makes it go down. The base being a number larger than 1 makes it go up. Now the last one on this page. These are not that hard, right? Especially with the calculator, it really makes life easier. So we're going to put 3 times 2 to the x, and then we'll put plus 4. And then we'll delete that. Okay? Let's try to, we don't even have to graph it, but we can graph it. Ooh, that's kind of weird. It's like stays kind of straight here and then it goes up. Okay, so let's see what that looks like on the table. So if we go way back to the left, well, look at that. It like gets smaller, 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 but it never goes less than 4. Isn't that interesting? And then it just turns into 4. Okay. And let's see, when we get to 0, it's 7. Wow, that's new. And all the other problems at x equals 0 is 1. Now it's 7. Okay. And then at 1, it's 10. So 0 is 7. 1 is 10. Is that right? 1 is 10. Okay. And then at 2, it's 16. Oh, starting to get bigger. 3 is 28. Okay, I think we're going to have to rescale this, okay? So instead of scaling like that, I'm going to put 10, 20, 30. Okay, and then I'll put 0, 1, 2, 3. So 0, 7. Oopsie. 0, 7 would be about there. And then 1, 10 would be there. 2, 16 would be about there. And 328 would be about there. And then we connect the dots. Okay? So, and then that reminds me of something that we should have been doing, which I forgot about. Draw the graphs of these functions using your GEC. We did that. For each, write down the coordinates of the point where the curve intersects the y-axis and the equation of the horizontal asymptote. So we didn't do this. We didn't write the equation of the horizontal asymptote. Now, where does it cross the y-axis? We could mark that by writing it here. We could say, hey, this point here is 1. And this point here is 1, right? And this point here is, we could write that it's 7. Okay? And then they ask for the equation of the horizontal asymptote. Now, if we look at this graph, it approaches on the left, we will see that it approaches 0. Okay? And if we look at this one, we can see that it also approaches 0. Okay? So the horizontal asymptote is the y level that the graph approaches. And in this case, it will be y equals 0. This is the asymptote. Okay? And this one will be y equals 0. Now this is the only different one. Now let's look at this one. We're going to graph it. Remember how it doesn't approach 0. It approaches this number here, whatever that is. Let's see what level that is. Do you look at the y value there? It's 5.43. Now it's 4.92. I'm getting closer and closer to the bottom. 4.38. 4.21. It's getting closer and closer to 4, it looks like, right? 4.13. 4.07. 4.03. Interesting, isn't it? So you see how it's getting very close to 4, but it's not hitting 4. And that's what an asymptote is. An asymptote is a line that the graph is getting close to, but it doesn't actually get there. Okay, so you can see that it's getting close to 4. So actually the asymptote here is y equals 4. And it's not a coincidence that this has plus 4 here. That's exactly where the asymptote comes from. So do you see on the others, there is nothing added to it? So the asymptote is y equals 0. But on this one, y equals 4 is where it approaches. Okay? So that's how you figure out what the asymptote is. When you have something added outside the exponent, that becomes the asymptote. Because the exponent itself, like this part, it always goes to 0 on the left or the right. So the only reason why the function would go towards something other than 0 is if you add a number like that. Okay? All right, so that's it for page 1.